Today we're going to talk about a different topic. Now, let me ask you a question before I move into this topic. Is there a book that you've read or a movie that you've seen wherein a person blew up into a giant?
Yeah,
What book is this or what story?
it's Five Children in It.
Ah, Five Children in It. Is that the title?
Yeah,
Yes. Okay, what else? Okay, that's probably one of the best examples for now. But what do you call that when one becomes very big? When one is transformed from a small shape into a bigger shape? What's another word to describe that? Ah, yes, one of you says enlarge, but I think your classmate means enlarged. So you are being enlarged. And so in maths, there's a topic called enlargement. And that topic is applied now in computer graphics. It's also applied in science studies, which we could really do later on. But I like to remind you of this in a different way, and we're going to use the various shape that we did. Okay, right now everybody get a pencil and paper, and I want you to draw. I want you to copy as soon as I put it on the board. Okay. Okay. Has everybody have a pen and paper?
yeah.
Great. So here, I'm going to start with this. Copy, draw an equilateral triangle. I want to enlarge the triangle twice. What shall I do? How do you enlarge? Say that again.
Draw it bigger.
How bigger? I could draw it, yeah, twice. I only said twice. How?
Without using a ruler.
Without using a ruler. So what you could do is, because I said to enlarge it twice, right? You just estimate it for now, because later on we're going to use a computer software and it's faster, or a graphing paper and it's faster, but we'll just go through a quick idea, yeah, to make it faster now. So to double it is essentially to make it twice, you just make it bigger like this. Twice, let me see, yes. And all sides should also be twice, right? Every side, so this is double the side, this is double the length of the side, and that's double the length of the side. So in a way, this triangle is twice bigger than this black triangle. Is that clear?
The screen's really fuzzy.
Say that again.
I can't see it. The screen's extremely fuzzy.
Yeah, it's really blurry.
Oh, can I use a different color then? So here, is red clear? Oh no. Okay. So the red triangle is bigger than the black triangle. Is that clear?
Yeah.
That means when the red triangle is bigger than the black triangle, it means that we have enlarged it at a scale factor of 2, right? So scale, I have to write that, scale factor of 2. That means you have enlarged the triangle but twice as much. Now, what if I enlarge another triangle, the same triangle, 3 times? So this means that we have to enlarge this 3 times, like this. So what is the scale factor of enlargement with the green in reference to the black one? How many times did I enlarge the triangle from black to green?
3.
3 times. That means I enlarged it 3 times. So here, the scale of enlargement, the scale factor of enlargement is 3. Is this clear?
Yeah.
Now we go to the next one is, now if in the small triangle, if each side of the triangle is 1 centimeters, right? The side, yeah, that's our unit of measurement. Yeah. If this is 1 centimeter here, 1 centimeter here, and 1 centimeter here, yes. What is the total length of the triangle, the sides of the triangle? It's 3 centimeters. Now that 3 centimeter, there's a special name in that in maths. What do you call that? When you add all the sides of a figure. So that one is called that's what we call, yes, thank you, perimeter. So here, oops, wrong spelling. Perimeter. So the perimeter of the black triangle is 3. What's the perimeter of the red triangle? What's the perimeter of a red triangle?
6.
Thank you. Because it's 1, 2, 3, 4, 5, 6. There you go. What's the perimeter of the green triangle? Thank you. It's 9, right? So here we have to put the word centimeter, centimeter, and centimeter. Okay. Are there any questions with this?
No.
Okay. I'm going to give you your first batch of homework, right? I want you to draw a triangle that has a scale factor of 6 and 8. Six and 8.
What do you mean?
So basically draw a triangle that is 6 times as large as
8.
the black one. Yeah, 6 times as large and 8 times as large.
So it's 2, is it?
And then calculate their perimeter.
Do you mean accurately or like in comparison to how many times bigger it is?
Yes, in comparison. We'll do the accurate stuff later on when we use a computer. Okay, is the homework clear?
I'm a bit confused. I don't get what you mean by 6 and 8. Is that 2 different questions though?
Yes, 2 different questions. Because here I've just basically missed 4, 5. You do the 6 and you do the 8.
Okay.
Okay, right. So here, thank you. We can do the same with the square, right? So here there's a square. Each side is 1 centimeter. If I enlarge that square with a scale factor of 2, what is the perimeter of the square? So
8? Would it be 8?
Oh, thank you for that. Thank you for the guess. That's really, really helpful. Yes, let's see. So if I enlarge it with a scale factor of 2, yeah, that's the scale factor. It means that I am that each side I enlarge by 2. Yeah, each side will be twice as big. So this one, that should be twice as big. This should be twice as big. This should be twice as big. This should be twice as big. So here the perimeter would be 1, 2, 3, 4, 5, 6, 7, 8. Thank you. Right? Right? If I haven't enlarged it, the perimeter would only be 4. Okay. Is that clear?
Yeah.
Okay. That's the same question would be, if I enlarge that square, yeah, with a scale factor of 6 and scale factor of 8, yeah, what's the perimeter of that enlarged square? Next, now we go to pentagon. Right? Triangle, square, pentagon. Here we got that here.
What are you doing?
Now each side of this would be 1 centimeter. If I enlarge this pentagon with a scale factor of 2, what is the perimeter? So I'll double this.
10?
Okay, thank you. Double this. I double this. Should be here. Right? I double. What? 1, double, and this should be double. Yes, and this should be double here. Double here, right? So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to have that perimeter. Right? That's the perimeter. Okay. That is going to be the same question. The question is, if I enlarge that pentagon with a scale factor of 6 and 8, what is the perimeter of the enlarged pentagon? And then the same with hexagon. Yes? The hexagon would be like this. Each side is 1 centimeter. If I enlarge this 6 times and 8 times, what is the perimeter of the hexagon?
Right.
Are the questions clear?
It's 2 questions per shape.
Yes,
Correct?
2 questions per
Okay.
shape. And it's an interesting thing because there's a pattern to it. Yes? But please draw the enlargement and tell me the perimeter. Are there any questions? Okay, if there are no questions, I just want to recap that today the class reminded you of the idea of enlargement, and this idea is used a lot in the computer industry, and that's why we don't have to think about it when people do graphics, because it's already in the program with the computer. But in the past, they have to really, really do it by hand. And it's the same true in the science. They use this quite a lot, this idea of enlargement. And the same with architecture. Architects use this quite a lot. Yeah, the scale of a drawing. Okay, if there are no more questions, that's it for today. You still have time to do the work. Do it now before you forget.